neural networks. Neural networks overfitting. Neural networks in practice overfitting. The problem of overfitting, underfitting. Models does not have capacity to fully learn the data. Data. So not able to fully. So underfitting. Ideal fit. Ideal fit. Okay, flexible is there. Flexible is there. Here data, here less data only, but here not that much. Ideal fit. Overfitting. Overfitting. Too complex extra parameters does not generalize well. Too complex extra parameters does not generalize well. So that's why we are doing regularization. What is it? What is it? Technique that constrains our optimization problem to discourage complex models. This is the technique that constrains our optimization problem to discourage complex models. Discourage complex models. Regularization. Why do we need it? Why do we need it? Improve generalization of our model on unseen data. From unseen data, we have to improve that generalization in our model. That's all. Regularization 1, dropout. During training, randomly set some activation to 0. Okay. This is training going on. Randomly set some activities to 0. Regularization 1 and continues. During training, randomly set some activation to 0. Typically, drop 50% of activations in the layer. Forces network to not rely on any one node. For in TensorFlow, tf.t, keras.t, layers.t, dropout of p equal to 0.5. Typically, drop 50% of activations in layer. Typically, drop 50% of activations compared to here. Here, Z1, Z1, 2, Z1, 4 only is there. So this one absent, this one, the Z1, 3 absent, Z1, 1 absent. So 50% only activation layer. Typically drop 50% only. This is one of the dropout model. Okay. This is one of the dropout. Here, press offset Z1, 1, 1, 1, 3. Regularization dropout. During training, randomly set some activation to 0. Typically drop 50% activation layer. That is same. forces network to not rely on any one node. That is, here z1 comma 2, z1 comma 4, here z1 comma 1, 1 comma 3, here 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 2 absent. Here 2 comma 2 is there, 2 comma 3, 2 comma 4 is there. Here also 50%. So here also same TF code. TF Keras is the library, layer, this is the layer, okay, this is the layer, drop out, P equal to 0.5%, only here total 4 node is there, here from that 4 node, here 2 node only available, okay, here 2 node only available, here 2 node only available, here also 4 node. Among these 4 nodes, here 3 node only available. 3 node only. Here Z2, 2, 1, 2, 3, 2, 4. Here 2, 2, 2, 3, 2, 4 is there. Which one is absent? Z2, 1 is the absent. Regulations 2. Yearly stopping. So stop training before we have a chance to overfit. Stop training before we have a chance to overfit. Before overfit, we have to stop that training. Early stopping. So training iterations loss in between this. Stop training before we have a chance to overfit. We have to avoid that overfit. So stop the training. So last how much? This much training iterations. So initially stop high. So iteration increasing time, that loss also reducing. So this is this green color training. This blue color testing. While testing time same, but loss increase. Testing time. While starting time TV loss. So sorry, loss increasing, no, here. So while starting time loss increasing, while train iteration is after some time it is loss reducing only, loss reducing. While testing time it is more than training, okay. Early stopping, stop training before we have a chance to overfit. Stop training before we have a chance to overfit. So same here, training iteration going on. This one testing, this one training, okay. While starting training iteration, loss is high. In testing also loss is high. While increasing that training iterations, loss is less. Here also loss is less. Here also less. While increasing corresponding. Early stopping is the same concept. Like that. If we are increasing point, in this point training, in this point training iterations, 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 in this point training iterations. What is going on? Regulations to early stopping. Yeah, stop training before we have a chance to overfit. So while initial stage training, after some time training, while initial stage loss is high, after some time loss is reducing, while after increasing iteration time, then loss also reduce, then loss is reduced, then loss is there. So stop training before we have a chance to work. So that's why reducing the forfeit, reducing the forfeit chance to forfeit, reducing, yeah. This is a testing according to that. Loss reducing. Here, but little increasing. And correct, no? Little increasing. Which one? Loss increasing. Okay. Compared to here. Here, after increasing, so training reduced. Training, the loss is reduced. Increasing training. While testing, loss increasing. This is loss increasing. This side. Loss increasing. Okay. So, loss increasing. Reversations yearly to yearly stopping. So here stop the training here. Stop training. Here where we have to stop training. So we have to stop training here. Okay, so both are correlated. So stop training before we have a chance to overfit. So here to be stopped. That's why this side underfitting. This is while stop training here overfitting. Core foundation review. Is understand, no? After stop training, here overfitting happening. Before stop training, here underfitting happening. That's why reduce the loss. Core foundation review. The perceptron neural networks training in practice. Structural building blocks, non-linear activation functions. Structural building blocks, non-linear activation functions. In these structural building blocks, non-linear activation functions here. This is the structural building blocks, non-linear activation functions. Okay, neural networks. Now we are review the core foundation. So perceptron finish. In neural networks, stacking perceptrons to form neural networks. Stacking perceptrons to form neural networks. Optimizations through backpropagation. Stacking perceptron to form neural networks. Okay, to form neural networks. Optimization through backpropagation. Like this. Okay. Training in practice, adaptive learning, patching, regularization.